Hello everyone and welcome back to another game development log. I have now implemented box collision detection as well as box to sphere collision detection and also collision physics with those cases as well. So I can show you here if we launch the game. We can spawn in a flying cube and we can shoot it. Probably if we hit, we can pretty much shoot boxes all day if we want. So collision detection between cubes are working really well now, and they also work between spheres. So that is what I've implemented, and I would say it works quite well. There's a little bit of buggy, but they work pretty well. They actually have no angular velocity when they hit, because my game engine doesn't. It does support angular velocity, but it doesn't work out good because angular velocity and rotation is described with Euler angles, which, if you may know, they're not good at interpolating, meaning like rotating. So objects will look really weird when they rotate. It could work, but not when it hits something. I will try to implement that when I can, because I have a lot of school and other stuff that comes before this. So I also, if you notice, I have also added a collider to the character. So the character or the collider doesn't necessarily need to be a box. It can be any cuboid shape. So in this case it is invisible, but it is taller than it's wide, and it's a bit, yeah, it basically fits snugly around the character, as you can see. If I can change this boulder, yeah. So it fits pretty snugly around the character, and you can just push around balls. The character's legs are currently infinitely strong, may need to be fixed. So collision detection works very well, and sometimes you teleport away when you're inside, completely inside of an object. So you can just stand in front of this and get pushed around when it finally hits you. So for another demonstration, I have created this giant slab that goes around. We can just brick.tiff. Brick. I'll create a new material here called brick, and it will have a brick.tiff, and it will not be reflective, and I think that will be fine. This is how easy it is to create a new material. So I have created this, hopefully, this concrete slab here that will fly through here. It weighs 5,000 kilograms, and you see that it hits the rocks and pushes them away, and gradually slows down in real time as well. So now it's moving a bit slower, and it's pushing more and more stuff and it gets more and more difficult for it to keep its velocity. And because the character is infinitely strong, you can just stop him. This a bit buggy when you have the character controls fighting against you. So it works with all types of colliders. I can, if I want to, lower this down, and then we can actually jump up onto top of it. So yeah, you can now stand on top of this slab. I have no friction yet, so it sort of works and sort of doesn't. And things will also, yeah, you can shoot on top of this, and so it all works extremely well. And now I'm currently floating. Okay, this slab just went underneath because I pushed it. So box collisions actually work really well now, and I have also fixed a common problem That was when you had, if you have two screens or the screen doesn't cover the entire screen that you have, you could move your mouse cursor off to the side and click it away basically. So if you were like trying to turn around, and you would click on something else behind it. So I have implemented a function in the framework class that will allow you to clip the cursor, and it has several clip modes. The first one is free to move wherever you want, and the second one is to clip it to the side of the window like this, and the third one is just to clip it straight through the middle into the screen and also hide it. And the cursor can also be hidden when it's in in any of these other states. So that has made it a lot easier to just aim and don't worry about your cursor going off the screen. Boom. If I lower the weight of the slab, I can push it around. I shall maybe just change back to... I had two here, weird. I can just change it back to my native resolution, and now I can basically just push this around like normal, because it weighs a lot less, and just push it a lot forward, and it will stop when it gets resistance. And you can also shoot it to make it go faster. And put down some cubes. And we're currently using inelastic collisions. Oops, I almost cancelled the recording. I need to use the cursor clip function. And you can also jump on top of it and just push it down. Because the character has gravity, well no, nothing else has. I think I should implement a jetpack of sorts. Boom, 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 boom. So it is all currently working perfectly, and as I said, I can make it rotate, but it will look pretty weird. Let's change to 0 to 1. So you can see that this is currently rotating, so it works. But the rotation is weird because we are rotating on all axes in Euler space. Yeah, we could, if we want, the rotation works better while you're only rotating around one axis at a time. 0.1, 0.0. Hopefully this should work. Okay, so now it rotates around this axis. So this works a bit better. And it will also push you sideways. So if we make it not rotate and then have quite a large mass, the small cube that we shoot, we can demonstrate, if not rename the project, that if we shoot, stuff would bounce off. And if we make it not go fast, like this, if we make it this stationary, it should work. And I pushed it. Okay, like this. If you shoot something off of it, it will bounce off at an angle. So angled surfaces work perfectly fine. And to calculate all of this, I'm using a separating axis theorem that will both check if there's a collision and calculate the minimum translation vector, which is a vector of the smallest distance that is needed to push an object outside of the other one. So I have this do collision physics function that will take in a collision, which just has the MTV and the two entities of the collision, and we'll do all of the physics. So that is all I have implemented this week, and for next week I will try to implement, or not next week, I will go on a vacation, but for the next vlog, I will implement convex colliders. I think it will be relatively easy of what I have now, because it will basically just consist of adding a separate class and making the axes dynamic. And I also will do some optimizing, because this code is really optimized the best as it could be. And let's just do some manual clearing here. So it could be a lot more optimized, and I'm also going to, instead of using spatial partitioning with I use like a grid space, I'm going to use a octree instead, which is the 3D analog of a quadtree. And I think that will work a lot better, as it can divide space more where it's needed, because here you have a fixed grid size, so it will try to increase or decrease it depending on the density of all of these, so it gets like an average number of entities per cell. But if there's like a chunk that is really dense, that will like all of those will be like essentially in one cell, so it can't be divided to where it's most needed. It will be across the whole scene. So a quadtree will be much better, because it can create much smaller cells where the entities are more packed together, and bigger cells where they're not as packed together. So that is what I'm aiming to working on next. And also giving this concrete slab some mass again of 20,000. This is mass. Okay, this should work. Giving it some more weight. And now this is going to knock everything out. Maybe we can make its whole way through. It's already slowed down quite a lot. You can try and match it with the character velocity. It's actually not nicer now when you have a character collider, because stuff won't get into your face and like clip as it did before, as you can't walk through stuff as easily now, unless there's low frame rate, which I need to fix with the octrees. Yes, it's made the whole way through. I will return as soon as I can and have enough time to actually do another vlog, and until then, keep on programming.